Hey guys. Hey, Richard, Reggie, when'd you guys get here? Nice shirts. Welcome back everybody to the Foundations of Algebra course. In our last lesson, we knocked off multiplication. But before we leave that, there's one more thing we need to talk about that's related to multiplication, and that's factoring. Now I know you guys have worked with that before, but this turns out to be a major deal in algebra. So let's take a look at it. Just as a reminder, an expression is factored if it's written as something times something. So for example, these expressions are factored. 2x, because it's really 2 times x. So is xyz, because it's x times y times z. Likewise, 2x times the quantity x squared plus 5x plus 1, that's factored. Don't get fooled by those pluses inside the quantity. In the end, it's really 2x times that whole expression. Just like x plus 1, that quantity, times the quantity x minus 3, right? That's factored. In contrast, these expressions are not factored. 2 plus x, that plus in between those two, not okay. That's a big nope. Just like 12x minus 4. Okay, we got some multiplication going on with the 12 and the x, but that minus 4, again, big nope. That is not factored. And likewise, 6 times the quantity x plus 8 plus 9 is not factored. Can you see the culprit? Yeah, it's that plus right there. The plus inside the x plus 8, that was good, but we can't have addition going on between those terms. Okay? Tell you what, just to make sure, why don't you pause for a second and just see if you can circle the expressions that are factored. And I'll check back in with you in just a second. Which ones are factored? Okay, hopefully you circled C and D only. Okay, see all that multiplication happening in C and in D, but in A and B, we've got subtraction and addition going on between those terms. Those are not factored, okay? Actually, let me get rid of those so there's no confusion. We're only circling the guys that are factored. Okay, turns out that the real important part of this is taking an expression that's not factored and factoring it, okay? So, for example, with numbers, okay, I know you've done this in the past. If someone said factor 28, that means you're going to take it and write it as something times something. Like, for example, 14 times 2. Now, that might not be the way that you were thinking of factoring when I said that. Like, you might have been thinking 28 is 7 times 4, and that's perfectly fine. There might be lots of different ways to factor a number or an expression, okay? They're all good. Just like 28, you could also write it as 28 times 1. Okay, you're really showing those things that are being multiplied. So for example, if you wanted to factor that expression, and again, just want to be careful. When I say that, I mean, we really want to see the two factors, okay? 3x squared y z to the fourth. A person might consider that as 3 times x squared y z to the fourth. That's one way to write it. That's factored, okay? And if you wanted to check it, all you do is just multiply the two factors back together and you better end up with the original if you factored it correctly. And in this case, if you notice, multiplying those two together, you just go straight across again, right? Just push them together and that's it. 3x squared y z to the fourth, done. Okay? Someone else could think of it as being factored as 3x squared times y z to the fourth, and that's perfectly good too. Multiply them together, you see you get the same thing, the original thing. And one third way is to take 3x squared y z to the fourth and write it as 3x squared y, group that all up as one factor, times z to the fourth. That's another way. In fact, there's lots of different ways, all right? So tell you what, let's try this. I'm going to ask you to factor an expression, but I'm going to give you one of the factors, okay? Like this. Let's say 5ab squared d equals 5a. I'm really showing what's being multiplied. 5a times some missing factor. So we got to figure out what's left, what's in there in the original that we haven't taken out yet. Well, we've got the 5 and the a. I see a b squared and a d. You too? Looking good. And again, remember, if you want to check it, just multiply them back together and you better get the original thing. And I think for sure, let's see here. If I just put those together straight across, yeah, of course. Get that original. Okay, looking good. How about 3xy squared? And one of the factors is x, and we want to figure out the companion factor. So we pulled out the x. What's left? Well, I see a 3 and a y squared, right? And if we multiplied those two back together, we'd have to do a little bit of commuting to end up, but we would end up with 3x y squared. We're good. Got it. Good factoring. X to the 10th. Well, one of the factors is x. So, okay, think about this. This is a little tougher because it's really hard to see the x in x to the 10th, but we know it's there. So x, what would have to be in that second factor to end up with x to the 10th? And just as a reminder, x to the 10th means x, 10 times. So we have one of them. How many more factors would we need in the second factor? 9. Good, good. X to the 9th. Okay, and I know it doesn't ask us to check here, but just if you wanted to check, you would multiply those together, and that would be x times x to the 9th. Well, 2, 3, 4, 5, 6, 9. So x times x to the 9th, and that's just 10 total x's. Yeah, we got it. We got it. Looking good. All right, how about this? What if, same number, x to the 10th, but now we factor out x squared times, what would that second factor be? And be careful. Be careful. This one's a little tricky. Okay, x squared. Is anybody thinking x to the 5th? Got to be a little careful with that, right? It's totally reasonable. I can understand what someone might be thinking when they say x to the 5th, but no, right? Because x squared means we've got x times x, two factors of x. We want 10, so how many more factors? Good. If you're writing them out in your head, I think you guys are on it. X to the 8th. Okay, x to the 8th. Two factors of x, 8 more factors of x. That gives us 10 factors of x. We got it. Good. Last one here. X cubed y to the 8th. First factor is x, y to the 4th. Interesting. Okay. Well, we got one factor of x. We need to multiply it by something else. So we'll get 3 factors of x. So guys, does it make sense to say we're going to need 2 more factors of x? Hope so. I hope so. And we got y to the 4th. That means 4 factors of y in the first factor. How many more would we need to get 8? 4 more. Good. You guys are on it. Y to the 4th. There it is. If you push those together, multiply straight across, commute the x's together, you're going to get that original. Beautiful job. But wait, what if, so far these have all been one-term expressions, just one little thing. What if you had something like this? So multiple terms. And we factor, so definitely not factors. See that plus going on between them? That's not factored. Now we're going to factor it. So x times, all right, well, to get 2 terms, I think that missing factor better have 2 terms in it, right? Because we're going to distribute the x through. The distributive properties come into our rescue again here. So just look at them term by term. 5x, we already have the x there. So what's left to multiply to 5x is the 5. You got it. Now, we need a plus. Now, in the second term, it's 2xy. We already have the x factored out, so the x is taken care of. What's left in that second term? 2 and a y. Those are the things we haven't accounted for yet. Beautiful. You got it. And if you want to check it, what we need to do is just multiply it together, just like before. This time it's going to involve a little bit of distributing. So x times 5 is x5, and x, so I'm doing this. X times the other term is plus x2y. And if we commute these around, write them in the order we're used to, look at that. We get the original. Yeah, good to go. Good to go. All right, how about this one? 3x minus 6 equals 3 times that quantity. If you want, you can pause it real quick. I'll meet you back in 30 seconds. Let's see what we get. Okay, the 3 is there. We'll take it term by term. In the first term, I don't think we've accounted for that x. So 3 times x, that'll get us back to 3x. We have a minus in there. Ooh, this is tough here. We don't really see the 3 in the second term, but think about it this way. 3 times something has to give us 6. So what's that something got to be? It's got to be 2, doesn't it? There you go. And if you wanted to check it, just distribute that 3 to each term of the second expression, and you will in fact get 3x minus 6. Good job. Good job, guys. How about this one? X cubed plus 3x squared, and we're factoring out an x squared. Ooh, all right, toughie. All right, x squared. We got 2 factors of x already accounted for. In the first term of the second factor, what more do we need? Well, we want to end up with x cubed, and that just means x times x times x, 3 factors of x. We've got 2. You got it. I heard it. I heard it. Ah, hey, how'd you get green? X. We just need one more x. Plus, and then what do we need out of that second term that we haven't already accounted for with the x squared? Good, just the 3. You got it. If you want to check it, multiply it back through, you're going to end up with the original. Beautiful job. Beautiful job. What we stumbled upon here is probably the main way to factor by pulling out a common element amongst the terms. Okay? So you want to look for something that all the terms have in common, and you factor that out. In our 3 examples, it was an x, a 3, and the x squared, 2 factors of x. All right, so let's build on that. Let's say you want to factor this expression, this algebraic expression, completely. Well, 3x plus xy. Well, let's take a look and see in that expression, what do they have in common? Is there something that they both have, both terms? Check it out. You guys seeing it? There's an x in there, isn't there? So let's make that our first factor. I'm really being careful showing that x in parentheses. All right, so what would be left? X times what will give us 3x? Well, what haven't we accounted for in that first term? The 3. Good. 3 plus, we need that to get the second term, plus what's left in the second term? X times what? Well, it's got to be that y, right? It's got to be that y. There it is. Beautiful job, okay? That's pulling out a common element or a common factor. Very nice. How about this one? 5xy plus xyz. Well, I'll tell you what. Let's jump right on the same bandwagon. I see an x in there. You guys see the x in there too? Excellent. X times, let's see, what's left in that first term? 5y. Good, right? And then plus, get that second term, we pull out the x. What's left? Just the y and the z. Good. All right, is that looking okay to you guys? That's factored. But you notice something a little bit different in the directions? I kind of blew past it and I didn't even pay any attention to it. See that word right there? Completely. Completely. They want us to factor it completely. We have factored it. We're fine that way. But completely means they want you to pull everything out that you can, as big as possible. Don't leave anything that's common to the terms. We got 2, 3, whatever. Okay? And if you notice, I see that both terms still have a y in common. So we should pull that out too. So let's give it another shot. Okay? Let's pull out not just that x that we did before, but also the y that they share. All right, well, what's going to be left was the same thought process as we had a second ago. We pull out the x and the y. So in the first term, we just have 5. And in the last term, we just have z. And if you notice, if you look at the above version, that's just after you pull those 2 green circled y's out, you got 5 plus z. We got it. That's what it means to factor completely. Okay, watch that word. How about this one? X cubed plus 4x squared. Completely. Okay? So I definitely see that they have something going on with x's. The first term has 3 factors of x, 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 x. And the second term has 4 and then 2 x's, right? 2 factors of x. So what's the most we can get out of both of them? 2. They both have 2 x's. The first term has an extra one because it has 3 factors. So if we factor out that x squared, what will we have left? Remember, it's xx. And the first term really expanded out, written in your brain or whatever, is xxx, 3 of them. So we need 1x left to complete that plus, and then x squared times what will give us 4x squared? Just the 4. There we go. Got it. Very nice. All right, you ready for this? Let's get nuts. Let's do this. This is a biggie. All right. So we're asked to factor this completely. So what I'm going to ask you guys to do is look at all 3 of those terms and see. I see a bunch of x's and y's. I see a 9 there. We can check that out. So see what all 3 terms have in common. And let's get out as much as we can. So how many x's do all 3 of them have, even if they have extras? And then how many y's? And do what you think is right with that 9. See if there's anything we can do with that. Why don't you pause it and we'll check back in a second. All right, let's see what you got. I'm super interested to hear how it went. Well, okay, we know that we've got, let's see, in the first term there's 2 factors of x. Oh, maybe we should talk about this. See the 9, the coefficient, the number is 9 in the first term. It looks like it's 1. We're subtracting 1 x to the 4th, y to the 5th. And then plus 1 x cubed y to the 4th. So between 9, 1, and 1, the only common factors they have, I think, is 1. So, all right, that's not going to really do much for us. So I guess we'll just leave that 9. Let's take a look at the x's. The first term has 2 factors of x, right? xx. Second one has 4, and the third term has 3. So what's the most we can get out of all 3? How many x's are common to all 3 of them? 2. Good. So let's put that down first. Okay? Every term has at least 2 x's, x factors. How about the y's? Same thought process. I see 3 in the first, 5 in the second, 4 in the third. So that means everybody has each term has at least 3 factors of y. So there's our factor. Let me put those in parentheses, and let's put in, we'll fill in the other one. So what do we need to complete that first term? Well, we got the x squared, 2 factors of x, 3 factors of y. We just are missing the 9, right? So that goes there, minus, right? How many x's are we short here that we want to pick up with our other factor? Looks like 2 of them. Ooh, cool. And same thing for the y's, isn't it? We have 3 factors in our first factor, and we need a total of 5, so we need 2 more. Plus, and let's do the same thing one more time. X squared, already taken care of in the left factor, so we need 1 more to get 3. And then same thing with the y's. I got 3 of them, I want to get 4 of them, so we need 1 more. Look at that. Look at that. Got this? I think you do. I think you do. It sounded really good, the stuff I heard you yelling. We got 1 more to go, guys. Excellent work on factoring. Tomorrow, division. I'll see you then.